Hello everyone. So this is the last part of superconductivity. That is the discussion of high temperature superconductivity and its application of superconductor. Okay. So the basic concept of the high temperature superconductivity means that superconductor with the high critical temperature. Critical temperature, you know, the temperature below uh, the okay. HTS means high temperature superconductor. That's mean the superconductor with high TC. TC means critical temperature. The superconductor whose critical temperature is higher than the temperature 77 Kelvin is known as high temperature superconductor. Why we take the 77 Kelvin? Because this is a temperature of liquid nitrogen which can be produced easily compared to liquid helium. That's why the superconductor whose critical temperature above 77 Kelvin, we recommended this. We recommend this superconductor in our daily life application or the different measurement or the instrument used in the research field. Okay, that's why we our community try to make the superconductor with the high temperature, that means high critical temperature superconductor. Okay, so if you look at the discover of the superconductor which was done at 1911 by Kamerling's Ohms of the material of Hg, that is Hg, mercury, right? So for mercury at first was discovered the superconductivity phenomena was firstly observed by Kamerling's Ohms in 1911, right? After that, whereas various discovered was happening, various material was developed or used as a superconductor. Uh, Among that, there are three importance are written here. After that, 1986 copper oxide, the whose TC will be 30 Kelvin, is much higher than previous one, and 1987 the yttrium barium copper oxide, this is a complex component whose critical temperature is 90 Kelvin, which is can taken as the high temperature superconductor because his critical temperature is greater than, which is greater, sorry, critical temperature is greater than 77 Kelvin. That's why this is called as high temperature superconductor, right? High temperature superconductor or high TC is called 77 Kelvin because of the liquid nitrogen, and liquid nitrogen is more beneficial compared to liquid helium. That's why we try to make the superconductor with the TC above the 77 Kelvin. Another one at 2019 lithium hydride was developed whose TC is 250 Kelvin. It's much higher and can be used in our in different measurement easily because the uh, cost to reduce the temperature is much less, right? This was developed by intermediates group at Max Planck Institute. Okay, this is the some example. You can see in this graph the development of the superconductor with the year in a different material. This is the 1911 ASG was first developed, and there are various metal converted into superconducting and various time. You can see there are complex compound are showing the higher TC, right? You can see here the material whose TC is higher than this liquid nitrogen temperature, these are known as the high temperature superconductor. Okay, you can see this is a graph. CNT is most useful, but yttrium, this barium copper oxide whose temperature is higher than the liquid nitrogen temperature. Okay, these are the uh, plot you can see easily. Next is the property of property of high temperature superconductor. There are some property of high temperature superconductor. This property is not much better than the low temperature. That is the superconductor with the lower TC is more beneficial in the point of view that of the highly conducting, that is the low resistive property was obtained in case of the TC is lower than 77. They shows the actual superconducting property, but in case of the TC greater than 77 Kelvin, they are much differ, is some differ from its superconducting property with some special property. That's why we listed out this property, that is the highly anisotropic structure of high temperature superconducting. Their Hall mobility is very low. The Hall coefficient is temperature dependence. Bonding of atoms are covalent. They are covalent bonding. Betrayal substance. These material are betrayal, and that's why they cannot carry large magnitude of current. In compare, this is the compare with the low temperature superconductor. Low temperature superconductor means the superconductor TC is 77 Kelvin, right? And this high temperature superconductor are lying between in superconductor of type 2. Okay, this is called as the hard superconductor. You know the uh, magnetic field nature, magnetization nature is like that with the H in the magnetization. You know this is HC1 and this is HC2. Okay, this is type 2. You all know that this is type 2 superconductor, and these high temperature superconductor are lying in this category. This is type 2 category, they lies, right? Then comes into the application of superconductor. If you can mate or we can mate the superconductor with the high temperature, because high temperature is useful, or the low cost, when low cost, that is the cost effective, we can use as a cost effective. If we mate, we can mate if we can make high temperature superconductor, then it is very cost effective, right? That's why we try to make high temperature superconductor. And the different uses are: number one, low loss transmission. Because low resistivity is low, that means the loss will be low. When the current will be transmitted one point to another point through the superconductor, the resistivity low, that means the loss will be low. Generally heat loss, there is a H equal to I square RT by J, you know that. If rho is low, R is low, then current will be high, and that transmission loss will be low. Next one is the fast computer chip. Since the resistivity low, the current can be flow faster. That means information can flow faster. That's why we can make supercomputer. That is the fast computer can be made by the superconductors material. Number three is magnetic resonance imaging, that is the NMR, which is mainly followed of the property of the quantum sorry flux quantization and the flux quantization and the effect of the squid measurement. You know the squid measurement, that is Josephson experiment or the Josephson property can be used in this measurement, and the biological sensing also be used. And you know very well about this squid also used in the flux into voltage conversion, magnetometer which can be used for brain, heart, lungs experiment, gastrographic, and the submarine. They are the different uses of the squid. And squid, you know, this is made by two Josephson junction like that, with this I think you know about the squid instrument, right? In the squid instrument the current will be not equally distributed, they are different due to the association effect. And by this measurement we can measure very low magnetic field, we can measure by the squid. This is the structure of the squid, okay. And we can measure very easily the um, very low magnetic field by the squid measurement, okay. And this is the additional notes with the thermoelectric property, you can watch this. And this is superconductor, this is a plain Cooper pair and so on. And this is a list taken from Google, tissue versus with the material. You can just overlook this material uh, to have a idea about the tissue of different material, okay. So there is an important graph in this presentation is by this you can learn about the material and their critical temperature, which is the important parameter of a superconductor, because this is the state of this material and this state can be obtained by the below of this critical temperature. That's why the critical temperature is the most important parameter of the superconductor. I think clear all of this, and this is the end of the superconducting. I will be give you the assignment in the later. If there is any query, may please ask me. If there is any question, please ask me.